In this short video, we'll quickly talk about how to find binomial probabilities using the TI-83. The function that we're going to use is binom PDF, and it takes the parameters in this order. You have to do, it'll produce binom PDF parenthesis, the number of trials, comma, the probability of success, comma, the number of successes. So to access that, we're going to go to second vars, and that will pull up the distribution options. So scroll all the way down and look for binom PDF. That stands for binomial probability density function. We'll access that. The number of trials goes first. So let's say we have 10 trials. The probability of success is, let's say, 90%, and the probability of success is 90%, and the number of successes is, let's say, 8. Okay, so what's the probability that we get 8 successes in 10 if there's a 90% success rate? Well, the probability of seeing that is 19.37. That's the same thing that we would get if we did 10 combination 8, 0.9 to the 8th power, 0.1 to the 2nd power. Now let's say we want to add a bunch of them together. Say we want the probability that x is greater than or equal to 6. Well, we would have to do it for 6, 7, 8, 9, and 10, and then add them all together. That would take a long time. So what we're going to do is produce a sequence of probabilities. So binomial PDF, in this case, we'll have 10, probability of success is 0.9, and we'll put an x right here to indicate that that's an unknown. Then we'll specify x to go from basically 6 all the way up to 10, so the s, number of lower successes, number of higher successes, and then we'll hit enter. That'll produce the sequence of probabilities, then we'll sum them up. So we're going to access the sequence, go to second stat, over here go over to ops for operations, and pick option 5 for sequence. Now we're going to go back and do second vars, down to binom PDF, 10 trials, probability of success is 0.9, comma, x successes. X will go from, comma, 6 all the way up to 10. Close the parenthesis. We want to add up all those probabilities. The probability of getting, so this is probability of getting 6, 7, and then 8, 9, 10 shows up in this whole list. Now we want to add up all the values in that list. So we'll do the sum function. Go to second stat. Instead of ops, we'll go to math. Sum, option 5, the answer. So we want to sum all of these up, so I'll hit second, the negative sign, and it will sum up all of those values. So the probability of seeing 6 all the way up to 10 successes is 99.83% if the probability of success is 90%. So this would be 0.9983. Very clever, easy way to do it. Now, using Excel, we can do the same thing. The Excel function is a little bit faster. All we need to enter is equals binom.dist, parenthesis, the number of successes, number of trials, probability of success, and then false. Don't worry about why, but we'll have that in there. So here I have a quick table set up. Here I'm going to place the successes. So let's say I have 5 trials. That means I could have 1, 2, all the way up to 5 successes. So rather than have to enter 1, 2, 3, 4, 5, I'm going to do 0 equals, in the next cell below it, reference, this is cell C4, so I'll do C4 plus 1. And now all I have to do is drag this, and it'll produce 0, 1, 2, 3, 4, 5. Alternatively, you can type them all in, but if you have a lot of trials, it could take a long time. I'll do equals binom.dist, parenthesis. Now see, it asks for the number of successes. Now the number of successes, I'll have it dragged from this column so I don't have to type in the number of successes. I will hit grab that from cell C4, comma, the number of trials is 5, comma, probability of success is 0.9, comma, we said to enter in false. We hit enter. That tells me the probability of 0 successes is 1 times 10 to the negative 5th. Now I'm going to drag this down by grabbing the corner, and that enters in the probability of this many successes. So I notice that the probability of, I should have had 10 trials in here. So we'll do 10 trials. I'll drag this down to 10.